Okay. So we'll start. I mean, you guys have your tests, right?
Yeah.
So the first one, this was something that he went over in class, number one. I mean, we talked about this multiple times. Things that affect the rate of a reaction. So, I mean, that's temperature, it's concentration, it's the presence or absence of a catalyst, and it's the physical state. So just a little bit about why. I mean, temperature, we're learning a lot about K values, the equilibrium constants, and how they only change with temperature. So it's easy to understand how if you heat something up, it may react faster or slower, dependent on if it's an endothermic or if it's an exothermic reaction. Does that make sense, how temperature affects? Concentration is apparent in a rate law. You write rate equals K times the concentration. So it's pretty obvious that if you increase your concentration, that your rate is going to speed up, okay? Catalysts, they do two things, and you'll learn this throughout your career in the sciences. They will stabilize your transition states, and they lower your activation energy, okay? That's the two things that they do. And so they will always speed up reactions, okay? And then the physical state, what you think about is, I mean, you think if you introduce a solid into a situation in which there's liquids, it's going to react at a different rate than if you would have added liquid to liquid. Okay, there's definitely a difference in speed there. So that was the main idea there, but those should have been easy points because we talked about it in class lots of times. So number two, this is testing your ability to be able to find a slope and to understand how to determine reaction rates at instantaneous points and at average rate, at an average, so between two different times and at a certain time, okay? So we talked about it in class of how we are supposed to do that. If it's an average rate of change that we're doing, we can pick 2 points on our slope and draw a line straight through those 2 points. So here's an example of how that happens. So let's say it's 50 and 20, because that's relevant to our problem that we have, okay? The way you do an average rate is you take this point at 50, and you take the point at 20, and you draw a straight line through those 2 points, and you calculate your slope, okay, using those two values. And then that's just y2 minus y1 over x2 minus x1. And so that's pretty basic algebra. I'm not going to really go into more depth of that. But the points that I used and that got me the right value was I used this is for number 2. Okay, we're going to talk about number 2 first, the instantaneous rate of change. Okay, and the reason I use those 2 points is if you look at your test and you look at the time that it wants you to calculate it. It wants you to calculate it at 30 minutes, okay? And so what I like to do is you get your ID card, okay, and you're going to put it up against the graph, up against the slope, and you're going to just draw a straight line through your card. So it barely touches the curve at time equals 30 minutes. Does that make sense? And then what I like to do is I just go anywhere on that graph where it makes kind of a nice point, anywhere where it's an exact value that it's easy to read, and then that's my point. And so that way there's less room for error. There's less room for you to miscalculate or to misjudge where that line actually is on the y-axis or the x-axis. So as far as that's concerned, that's how you do an instantaneous rate of change. It's something that we've talked about in class as being it's an average rate of change, but as you shorten the distance between the 2 times, your rate becomes less of an average rate and more of an instantaneous rate, okay? Any questions about that? About how to solve for an instantaneous rate of change? Okay. So going further with that problem, we have So that gets you negative 0.047 over 40, which equals negative 0.001175. All right. And if we simplify that to scientific notation, we're going to get. Well, I guess we don't. It doesn't even matter. We could keep it at that point because there was a huge range that was accepted on the answers. Okay. And just a little bit of, I forgot to tell you guys this in the very beginning, but what's going to happen after this review is I'm going to post the key with the answers and how they were graded. All right. And I will also post all this work for each problem, so it's a step-by-step kind of how I went through and did the problems, and I try to do it as neat as possible, so that you can go back and follow if anything kind of seems foggy while we're doing it in class. So that falls in our range, and now I want you guys to notice that it's a negative number. The reason why it's a negative number is in the question it asks for a rate of change. So when we have a rate of change, we have to designate what way it is changing. A negative sign means it's going down. It's a negative slope, and that's what it tells you. So you're losing concentration as time goes on. Now, if it would have asked for rate of disappearance, then it would have been a positive value, because rate of disappearance is what tells you it's disappearing. So rate of appearance, right? Yeah, rate of appearance rate of appearance would be a positive. Rate of appearance and rate of disappearance are always positive numbers, because a rate of disappearance, it's already telling you that species is disappearing. The concentration of it is going down. Rate of appearance means that the concentration is going up. Okay. And so in the name, it designates what the sign is of the number. And so in that case, you keep it a positive number. Okay? Okay, so the next one, we're talking about the average rate of appearance. All right? So first off the bat, we know it's going to be just a positive number. We don't need to worry about sign because it says rate of appearance. And it also gives you the 2 points that we're going to use. All right? So if you check out your test, and you can see where x equals 20, I would think that the y is about 0.039. Okay? Does everyone agree? And at 0.50, I would say it's about 0.009. Agreed? Okay. So then, if you know that, then you're just going to pick 2 points, the 2 points that it gives you, which in this case happen to be 50, and it's about 0.009. There was a little bit of room for you could have got that a little bit different, and you still are in the range. Okay, and then the other point that I got was about 20. Sorry, 20 and about 0.039. Any arguments so far about those 2 points? Or any question of how we got those 2 points for number 3? We're on number 3. Okay? And then it's just slope. So you're just trying to find the slope of that line. So you just put in which gets you 0.001. And it actually gives you a negative number, but like I said, you guys know that you don't report it as a negative number because it's a rate of appearance. Okay? Okay. I don't even know if that actually would be negative. It would, but anyways, it's only a positive number. So it wouldn't have mattered what the sign is. It doesn't matter what you were minusing, as long as you state it as if this was x1, this is y1, this is x2, and this is y2. Okay, any questions? Yeah.
So I did the other, I did 0.009 minus 0.039 minus 20.
Okay.
Is that?
Yeah. So
Can you do that?
so you just switched them.
Mm-hmm.
And what'd you get?
Well, I actually did 0.09, so I got it wrong.
Okay. Yeah, you should be able to do that. Yeah, you should be able to do that. It should be fine. Yeah.
I know
Fair
what
enough.
she did, but then I used 0.009, but I got negative 9 points times 10 to the
Yeah, that's bigger.
You got what?
negative 9.7 times 10 to the negative fourth,
Okay.
and I only
Okay.
I get the same.
Dylan.
I got .0015 and they marked it wrong. Didn't give any points for it.
Point what?
0015.
Okay. So let me just say another thing about this review session. So you're going to notice things that you should have you should have gotten points for, or things that were graded wrong. This is kind of not the area, the time to do it, because every TA graded specific problems, and so what you got to do if you feel like you got kind of shortchanged on something is you go and talk to that TA. After this review, I'm going to post the key, and on the key it's going to have who graded which problem. On Learning Suite is their emails and all their information for you to be able to get in contact with them and talk about those kind of things. Oh, I did it this way and I got the wrong answer. Okay? So this kind of part is we're just kind of going to go through the way I did it, the way the TAs did the problems. Okay? Is that okay with everyone? So just wait until tomorrow or when you have a chance to email the specific TA who graded it, and you can get that you can get all that figured out. Okay? All right, so that takes care of number 3. Any questions about number 3 besides questions about points? All right. Okay, so moving on to number 4. So with number 4, we're going to have to determine what order a reaction is, and all they give you is the concentrations and time. And so we learned in class that the way that we solve problems like this is we determine so it gives us the concentrations, and then we take the natural log of the concentrations, and we take the inverse of the concentrations. And dependent on what function we do to it, whatever one makes a straight line, it will tell us what order the reaction is. So if you do the LNs, the numbers that you get are these. And then for the inverse, and now there's a couple ways that you can do this problem at this point. You could look at this and kind of notice that it's a kind of a linear progression as you go through these different numbers. But if it's not obvious to you at first glance, there's ways that you can do it. And so the way that I do it, if I can't see it, is I begin to take points. And so if you remember, we have times as well, and the times are 0, 1,000, 2,000. Does it jump to 4,000? At that point?
Yes.
And then 8,000?
Yes.
And then 10,000, right? All right, and so what you can do is you can take different points. Can you see how 0 to 100, can you tell you that this is a point on a graph? Can you see that? And that 1,000 and negative 10.31 is a point on a graph? And so you can determine the slopes between two different points, all right? And so if you were to take the slope of this point and with another point, the slopes would be the same if it was a straight line, okay? So the 2 points that I picked were okay? Any question about why I chose those points? You can choose multiple ones. It doesn't really matter. but I just picked 2 ones that were kind of simple, the first 2 ones. All right, and those will both get you. So that's kind of a big clue. Okay, this is probably first order. If I was on a test, I would probably do 1 more point to see if it was the same. But at this point, you got a pretty good clue that what kind of reaction it's going to be. And then just looking at the inverse, you could tell it. I mean, it jumps 20, and then it jumps by like 60, and then it jumps by a whole lot. So you kind of can look at that and judge and see what kind of order it is. Any questions about that? About number 4? Okay. And then number 5 is determining the rate constant. And so we only have concentrations and we only have time. And so there's an equation that you guys should be familiar with. And it is okay. And now you can use multiple AT. The AT stands for A at a certain time, and A naught stands for A initial. And so your initial and your AT, your A naught and your AT can be any one of the numbers as long as you keep your T, as long as you write your T right. Your T has to be correct. Your T, if you're looking at your chart, if you start at 1,000 and you go to 4,000, your T has to be 3,000. Okay, it has to be the time that elapsed between the 2 points. But you can pick any of the points and it will work. So the work that goes on is so I picked the point at 1,000 and I picked the point at 0. All right, so my A0 is 1 times 10 to the negative 4th molar, and my AT is going to be 3.33 times 10 to the negative 5 molar. And because I chose that interval, my time is 1,000 seconds. All right, so that simplifies to and that goes all the way to, well, I'm just going to, so that's negative 1.099617. I'm just going to divide that by negative 1,000. The reason I can do that is that negative sign can distribute all the way through that. So I can just divide by negative 1,000 to get my K into a positive number. And so that means that gets me K is equal to 0.0010996. Okay? And at that point, you might be tempted to just put that number, but you look up at the top, and you have to take into account sig figs, all right? So the sig figs that were required in this problem are, you need to have 3 sig figs. And the reason that you know it's inverse seconds is it wants to know the right units, and if you know a reaction is first order, then what does that tell you about what the units have to be? Rate always is expressed in molarity per second, right? So you need your units of your K to cancel out in a way that your rate equals molarity per second, okay? So in this case, our rate law is first order, so that means it's just molarity. And in order to get molarity per second, you're going to have to have seconds on the bottom, which that's what S-1 dictates or indicates, okay? Any questions about 5? Okay, good. Number 6 is a half-life problem. And there's a couple ways that you guys would have been able to solve this. I'm going to do the way that's kind of the newer way that you guys have learned, which is AT over A0 equals 0.5 to the t over t 1/2. Okay? You guys should be familiar with that. And so now you kind of got to read the problem and understand what it says. So the guy, it's a guy it's a technician, and the technician, he installs this cobalt sample and it passes 200 weeks. So that what that tells you is that it's been 200 weeks since. So you have two different samples. You have a sample at 200 weeks and you have a sample right when he puts it in, okay? And so our AT turns out to be 34.4. And I think it's in grams. Is that correct?
It's in milligrams.
Milligrams. Does it matter if they're both in milligrams and they're both the same substance? No, because it's a ratio, okay? If it's a ratio of the same measurement and the same species, then you don't need to change it. You can just keep it in that unit. You don't need to go to moles. Okay? So it's 34.4 over 56.9 is equal to 0.5 to the 200 over x. All right? Because we want to solve for the half-life. So half-life is going to be x. I'm just going to denote it with x. And so that's going to simplify to 0.60456 equals 200 over x log of 0.5. And I'm going to log this side as well. I'm going to kind of skip a step. Any question about how I did that? Or did you guys follow that? Did you follow that?
Yeah.
Okay, good. Okay. And then you're going to divide by log 0.5. Now I'm going to leave this board up. And you get and then x is going to equal 200 over 0.72604. And so x is going to equal 275.46 weeks. And that's your answer, and you just look at your sig figs to see what you need to express it in. And it looks like 3 sig figs was the lucky ticket there. Points were given if you gave it in years or if you gave it in any other unit that was equivalent. Okay, you weren't docked for units as long as it was appropriate to your number. Questions about how I did number 6? Okay. Number 7. Here it is. So there must be some question you guys are waiting for. What question? What question do you want to hear, Caroline?
Huh?
What question are you here for, really?
That one.
Okay.
Yeah, that was it.
What about you?
This page.
Okay. Matt,
That one.
that one. Did that make sense? Did that click?
Yeah.
Or did I go a little too fast?
No, like that totally clicked.
Okay.
I'm just like kind of happy because I think I'm gonna get points back for it.
Okay, good. What about you?
This page.
This page coming up right now? You too?
11.
11.
Yeah, same.
On you?
Number 3.
Number 3. Did I cover that good enough?
Well, I got the answer.
Okay, so you
got
just
the
want to
number
talk to someone.
wrong.
Oh, that's fine. Okay. All right, so number 7. So 7 is a lot of boards we're going to be filling out with 7. So let me lower this one again so I can use it. All right. So there's a couple of ways that you guys can go about these types of problems. As you do practice and as you practice looking at these kind of charts and kind of seeing trends, you'll be able to sometimes be able to look at a chart like this and be able to tell what order each one is. But there's also a way that if you get stuck and you can't tell, there's a surefire way, and that's the way I'm going to show on the board. Okay. So we talked about it in class. Does this look familiar? Can you give me some feedback here?
Yes.
Okay. And the key to understanding and to get these problems right is you have to pick a line. You have to pick an experiment in which one of your species stays constant. Okay, that is so important for you to be able to cancel one of those variables out in order to be able to isolate the n or the m. Okay, so in this one I used So immediately you can tell, okay, this cancels. And now we're looking at that situation. So I'm gonna move over here and it's gonna, that equals 0.332 is equal to 0.333 n, okay, to the n. And now the reason I could do that, maybe if you didn't understand that step, is 0.005 over 0.015. That's the same thing. It's just you can you don't need to work if the m's are the same. You just divide the numbers as if they were just by themselves. And so that gives you 0.333 m. And then if you know your log rules, you can log. You divide your log over to get m by itself. And then that equals about 1. Can you guys see how it equals about 1? They're almost the same thing, right? So we just decide m equals 1. And we're good with that. We're good with that up to that point. Now we just have to pick another experiment. That cancels out, okay? And you're looking at something like this. And that simplifies to 0.5 to the n. All right, so remember what I said. You can kind of ignore the m's because the superscript is the same. And you can tell that, I mean, you should be able to look at that and say that's about 0.5. Exactly 0.5. And then you follow the same steps. You're going to, you have 0.2497. You're going to log both sides. And you end up getting n log 5 equals log 0.2497. And that will get you n equals 2. So now you know both of your superscripts. You know what order ammonia is, and you know what order nitrite is. Okay. So with that information, you're ready to write rate log. So now, just a little word about this because there could have been some confusion. In order to have your rate law be exactly correct, you have to have a k constant. Your k constant has to be a number. okay, in order to have a complete rate law. However, in this situation, because number 9 asks for the rate constant, it kind of was confusing because it kind of made you guys think you didn't need to put it up at the top. So just in the future, know that in order to write a rate law, you have to know the K. The K has to be a number, okay? You can't just put the letter. Now, you guys were given points for both ways. So just because it's kind of confusing on number 9. But yeah, just so you can understand that. All right? Any questions about knowing or about writing rate laws using those charts like that? Okay. So number 8, we know that the ammonia is a first order, and we know that the nitrite is second order. So what's the overall order? It's 3. You just add them up. Okay, it's pretty straightforward. To find the rate constant, all you have to do, since you know the superscripts, that looks kind of. You can look at this chart and you can say, oh my gosh, I have a rate, I have concentrations, and I have superscripts, and I'm just missing one variable. So you could solve for the K. So that's exactly what we're going to do. I want you guys to pay close attention to the units here, just in case that was unclear to you. I'm going to call KX because I love math, and you always deal with X in math. So notice that's squared. This one is squared. And so that simplifies to 4.32 times 10 to the negative 5th molarity per second is equal to X times 8 times 10 to the negative 4 m cubed. Okay? And then you just divide by 8 times 10 to the negative 4th molarity cubed. And you should be able to see the units, what happened there. That's your answer. Okay? And so, I mean, that was your, and on that one, they wanted 3 sig figs on that one. 5.42 times 10 to the negative second. Molarity to the negative 2, seconds to the negative 1. Okay? Okay. Moving on to number 10, then. 10, I'm not even going to do on the board because what you have to look at on number 10 is, okay, do I have the same species on both sides of an equation? All right? If you have them on both sides, you cross them out. They're intermediates. So the first thing you had to do on number 10 was see that N4010 was on the right side in the first step and on the left side in the second step, so those cross out. And then you look at step 2, and you notice that there's an O3 on the right, and then there's an O3 on step 3 on the left. Those cancel out. You add up the ones that are left over, and you get 2N2O5 yields 4NO2 plus O2. Questions about that? That one's pretty straightforward. And number 11 is writing the rate law for this proposed mechanism. And this one should have been kind of a gimme because he did this in class. He did this exact problem in class. However, we will still go through it because it's really good to just understand and maybe see how someone else did it. And this is how I do it. And I think it's pretty helpful to kind of look at it like this. So I look at it and I say, okay, where's the slow step? All right? On this one, slow step, step 2. I write what should the rate law be for step 2? That's what the rate law should be. But now you should look at that and say, oh crap, that doesn't look right. Because we cannot have intermediates in our rate law. All right? So you have to solve for the concentration of your intermediate in terms of reactants. A reactant is something that we know the concentration of, okay? And that's a key idea that you need to have when you're dealing with these problems. You can never have an intermediate in your rate law. So you go up to the first equation, the fast and reversible one, And you remember that K1 of N2O5 squared is equal to K negative 1 of N4O10. And remember, what do we want to solve for? We want to solve for this term. We want to solve for the concentration of N4O10. So we divide by K in the K in the reverse reaction. Okay, so now we take this and we plug it into that. Okay, we take that whole term and we plug it into the new concentration. Notice that this K, we can call it K2. It's not the same K as this. It's not the same K as this. It's a different K. Now, it doesn't matter if you put 2, but it just has to be different. You have to understand that it's a different K value. Okay? And once you do that, that's going to be your answer. Okay? Any questions about how I found that?
Can the K's be reduced down to 1K? Just
Yes, they can, but if you read underneath,
yeah.
it says do not combine the rate constants. Okay? Yeah, you totally can because it's just a number. But the direction specifically said not to. So that's why he kept it like that. And he did that because he wanted you to understand. He wanted to know if you understood why they could combine. You know. So that's that problem. Really neat problem. He could have made it a lot harder, I thought, but I think he went easy on you guys. So that's that one. Number 12. All right, what's a transition state? Transition states are the peaks. Okay, that was something you kind of should have just known from your reading and things like that. So that's just straight up. There's 3 transition states in that graph. What step of the reaction is fastest? Okay, the way that you understand, the way that you can determine that, you want to look for a step. So I'll draw it. So we talked about in class, like if you have a activation energy diagram, this to here is known as our activation energy, okay? That's the energy that you need in order to make the reaction happen, all right? And so a thing that you guys will learn as you learn more about chemistry is that the higher your activation energy, the slower that your reaction is going to be. So what you guys had to do on this graph is look for the step that had the lowest activation energy, the lowest little hump, from the intermediate to the next intermediate or to the final product. All right? So on our graph, you look at A to B. It's not that high. It's definitely faster than the B to C. Do you guys see how it's faster than the B to C? But then you look at the C. Look how little the hump that C has to have to go over in order to get to D. It's very small. So that cues you in to know that, okay, C to D is my fast step. This is the fastest step in this graph. Okay, now it asks, is the fastest step endothermic or exothermic? We know that it's exothermic because our C is higher in energy than our D. So you learn that if there's a decrease in energy from the intermediate to the next product or intermediate, then that's an exothermic reaction. And the same is true for the inverse. So number 15, it says it's the overall reaction, endothermic or exothermic. You look at your point A and you look at your point D. D's higher in energy than A, so therefore it's endothermic. Okay? Questions about interpreting that graph? Beautiful. All right, 16 and 17, and then we're done. All right, so this one was kind of, I think, the problem that he really wanted you to think outside the box. All right, that's kind of what I saw when I read it. The first thing that you need to understand in order to go about this problem is why they gave you rate 1 over rate 2 equals K1 over K2. You have to know what equation you're going to use in order to solve this problem. So you should have went to your equation sheet and you will find this equation. And actually, I'm just going to go through the steps that I took. So I looked at it first and I said, okay, 86 over 59 is going to equal to K1 over K2. Questions about how I got there? I took 2 points and I said, okay, that equals K1 over K2. Well, in our equation, it's K2 over K1. So I'd say, okay, 59 over 86 equals K2 over K1. All right, now that's important because we have an equation that is ln K2 over K1 equals negative EA over R times 1 over T2 minus 1 over T1, okay? Notice what units your R is.